Pluto isn't a destination, it's a one-way trip. There are thresholds in this universe where crossing them and returning are not two sides of the same journey. They are two entirely different journeys, and only one of them is possible. Pluto is one of those thresholds. It has been sitting out there for 4.5 billion years, frozen, dark, impossibly quiet, and it does not care about your plans. Not your ambition, not your technology, not your will to survive. The physics that governs Pluto is the same physics that governs everything, and it has already decided how this story ends. The question this video is going to answer isn't whether we could reach Pluto. We already did that. The question is, why does reaching it, truly reaching it, landing, standing on it, living on it mean you are never ever coming home? Let's start with the number that rewires everything. 5.9 billion kilometers. That is the approximate distance from Earth to Pluto when the two worlds are closest to each other in their orbital paths. When they are farthest apart, that number climbs to over 7.4 billion. To put that in terms your nervous system can actually process. The Moon is roughly 384,000 kilometers away. Mars, at its closest, sits about 54 million kilometers out. Pluto, at its nearest, is over 100 times farther than Mars, and we've sent something there. In 2006, NASA launched a spacecraft called New Horizons, the fastest human-made object ever fired into deep space at that time. It left Earth at roughly 58,000 kilometers per hour. It used Jupiter's gravity as a slingshot, squeezing out every last drop of speed physics would allow. It was an engineering achievement of almost absurd ambition. It still took 9.5 years to reach Pluto. 9.5 years. And here's the part that quietly changes everything. When New Horizons finally arrived, it didn't stop. It couldn't stop. It flew past Pluto at full speed, close enough to photograph mountain ranges and plains of nitrogen ice, snapping images for a few extraordinary hours. And then it kept going, into the void beyond, because stopping wasn't an option. Stopping requires fuel. And the amount of fuel needed to slow a spacecraft down from interstellar range velocity is staggering. Which brings us to the equation that has quietly killed every serious proposal for a crewed Pluto mission before it ever truly got started. In 1903, a Russian schoolteacher named Konstantin Tsiolkovsky wrote down a formula. You don't need to see it to understand what it says. What it says, in plain terms, is this. The fuel you need to move a spacecraft depends on how much the spacecraft weighs, including all the fuel already on board. Read that again slowly. Every kilogram of fuel you carry requires additional fuel to carry that fuel, and the fuel you need to carry that additional fuel requires even more fuel to carry it. The equation doesn't add, it compounds. Exponentially, the heavier your spacecraft, the more fuel you need. The more fuel you need, the heavier your spacecraft. The problem feeds itself until the numbers become, quite literally, physically unreachable with any launch system we have or are likely to have in the near future. To land a crewed spacecraft on Pluto and then take off again, to give those astronauts the fuel they would need for the return journey, you would need to carry so much propellant that the mission vehicle would be larger than anything humanity has ever built or launched. And that's before you account for the 9.5 years of life support, food, water, medical equipment, and psychological infrastructure required just to survive the transit. There's another piece people rarely mention. On the way to Pluto, you can use the gravity of Jupiter and Saturn to slingshot you outward. The outer planets act like a kind of cosmic on-ramp, but on the return trip, there is nothing at Pluto to throw you back. No nearby gas giant, no gravitational assist. You would need to generate every joule of return velocity entirely from your own engines, from fuel you carried with you, from a tank that has been depleting for nearly a decade. The ladder, in other words, doesn't just get harder to climb the higher you go. The ladder gets heavier. Assume for a moment that someone solves the fuel problem. Assume the engineering catches up. There is still a second wall, and this one isn't made of math. This one is made of time and isolation, and the specific, peculiar fragility of the human mind. At Pluto's distance, a radio signal traveling at the speed of light, the fastest anything in the universe can move, takes between 4 and 6.5 hours to reach Earth. One way. A crisis happens. Equipment fails. Someone is injured. You send a message. Earth receives it, minimum 4 hours later. Their response travels back, minimum 4 more hours after that. 8 to 13 hours for a single exchange. You are not just far from home. You are 8 to 13 hours away from a conversation. Think about what that means during a medical emergency. Think about what that means when a system fails and the mission commander needs guidance. Think about what that means on a quiet Tuesday when someone just needs to hear a familiar voice. There is no real-time anything, no live communication, no immediate reassurance, no rapid response anything. You are, by every meaningful measure, alone in a way no human being has ever been alone before. Studies on Antarctic, winter-over cruise, people isolated for months in the coldest, darkest place on Earth, document something researchers call the winter-over syndrome. Cognitive slowing, emotional blunting, a kind of psychic compression that sets in when the stimulation of the world is removed for long enough. And Antarctica still has an atmosphere. It still has sunlight, at least seasonally. It still has the knowledge that a rescue plane could reach you if things went badly enough. None of those things are true on Pluto. From Pluto's surface, Earth is invisible to the naked eye. Not dim, not distant, invisible. The sun itself looks like a bright star. Extraordinary, yes, but not warm, not life-giving. Just a point of cold light among thousands of other points of cold light. The greatest threat to a crewed Pluto mission might not be the cold, or the fuel, or the radiation. It might be the silence. Let's say someone goes anyway. Let's say the mission is designed from the beginning to be one way. What does life on Pluto actually look like? The surface temperature hovers near -230 degrees Celsius. The atmospheric pressure is roughly 100,000 times thinner than Earth's, a functional vacuum. The terrain, as New Horizons revealed, is strangely beautiful. Vast plains of nitrogen ice, mountains made of water ice rising 3 kilometers high, a thin haze of complex organic molecules drifting in the near-airless sky. There is something almost tender about its strangeness. Pluto is not hostile in the way a storm is hostile. It is hostile the way a vacuum is hostile. Not aggressive, simply indifferent. Gravity on Pluto is about 6% of Earth's. Walking would feel like floating a kind of perpetual gentle lurch. But that same low gravity would accelerate the skeletal and muscular deterioration already underway from years of weightlessness in transit. Bones that began losing density in the first weeks of the journey would, on Pluto's surface, have no reason to rebuild. The body, quite literally, would forget what it was built for. Energy would come from radioisotope thermoelectric generators. The same nuclear decay technology that kept Voyager 1 transmitting for nearly 50 years. Food would need to be grown in sealed, pressurized habitats under artificial light. Water would need to be recycled with near-perfect efficiency. Air would need to be chemically manufactured and maintained. Every single system that Earth provides for free warmth, breathable atmosphere, drinkable water, food, gravity would need to be engineered, maintained, and protected indefinitely by a small group of people at the edge of the solar system with no resupply and no rescue. Survival would be possible, technically, theoretically, in the way that a single candle in a vast dark room is technically, theoretically, light. Return would not. In 2013, a private organization called Mars One announced it was accepting applications for a one-way mission to Mars. Over 200,000 people applied, not out of desperation, not out of nihilism, out of something that looked, from the outside, almost irrational, and from the inside, apparently, felt like the most rational thing they had ever done. The first humans who crossed the Bering Land Bridge didn't know there was a continent on the other side. The Polynesian navigators who pushed their canoes beyond every visible horizon, thousands of years before GPS or satellite communication, sailed into absolute uncertainty, with the quiet conviction that the going mattered, even if the coming back didn't. History is full of people who chose a threshold, and crossed it knowing they might never return. We tend to call those people brave, sometimes reckless, but rarely do we call them wrong. Because here is what Pluto quietly reveals: if you sit with it long enough, the desire to go somewhere you cannot return from is not a death wish. It is the oldest form of human courage. It is the belief, irrational, beautiful, stubbornly persistent across every culture and every era, that the going matters more than the coming back. That what you find, what you know, what you stand in the presence of, changes something. Not just for you, for everyone who comes after, for the species. Pluto is not a tragedy. It is a mirror. It shows us the absolute outer edge of what we can reach while still remaining tethered physically, emotionally, practically to home. It is the first place in our own solar system where the return ticket doesn't exist. Not because we failed to build the right rocket, because the universe drew a line, and the line is honest. Every boundary that physics reveals is also a revelation about what we are. We are creatures built for return. We are built for the warmth of a sun close enough to feel. We are built for real-time voices and drinkable rain and the ability to stand on a planet that actually wants us there. Pluto doesn't want us there. It simply exists there, ancient and silent, nitrogen-frosted, waiting with the particular patience of something that has never needed anything, and somehow, from 4 billion miles away, it manages to teach us something true about who we are, about the shape of our reach, about the edges of the life we were made for. That, maybe, is worth something, even if no one ever goes. If this made you think about distance differently, about what we reach for and what we leave behind, I'd genuinely love to know what you took from it. Drop it in the comments. And if you want to keep going deeper into the parts of space that quietly change how you see everything else, subscribe. That's what this channel is for.